let's talk about stem and leaf plots. Not only creating them, but what can we learn from them? So first off, a stem and leaf plot is a way to organize quantitative data. So dealing with numbers. And because of the way we create them, they're really best for smaller data sets. All right, so let's go ahead and do this. Let's create a stem and leaf plot for the following set of data. Now we have a set of numbers: 34, 46, 32, 34, 54, 27, 26, 43, 42, 45, 36, 38, 26, 27, 34. Woo! All right. So the easiest way to do this is to start with what we call the stems. We can see that all of our numbers are 2 digits. So the first digit in all of these numbers will be the stem. Our smallest numbers are in the 20s. Our largest numbers are in the 50s. So our stems are going to be 2, 3, 4, and 5. Now the leaves are the second digits. So first, let's identify all of our numbers in our 20s. So I see a 27, a 26, a 26, and a 27. Okay, that's it. I have 4 numbers in my 20s. 2 of them are 26, and 2 of them are 27. Now, you'll see here that I list them all. So you want all numbers to be listed in your stem and leaf plot. And you can list the items or the values here in ascending order or descending order. So least to greatest, greatest to least. I usually do, lowest to biggest here. Okay, now I like to cross out the numbers after I use them just to make sure I have them all. Okay, so now let's go to our 30s. So I have 34, 32, 34, 36, 38, 34. Okay, so I have a 32. Let's cross that one out. I have a 34. Let's cross it out. I have another 34. Let's cross it out. I have another 34. Cross it out. And then I have a 36 and a 38. Right? I like the cross out method because then I know I have them. You miss one number and it throws everything off. Okay, let's go to the 40s. 46, 43, 42, 45. The smallest one of those is 42. Then I have a 43, a 45, and a 46. So the only number I have left is in the 50s, and that is 54. And that's all of my data. So now, looking from this, I can tell a lot of different things. First off, before we get into that, I want to talk about the key. So generally, you will see something like this: 2 line 6 equals 26. Because you could have decimals, which we're going to do here in just a moment. So it is important that you have a key somewhere to show. All right, now let's talk about what we know from just looking at our stem and leaf plot. We know the minimum value is 26. We know the maximum, the maximum value is 54. I know that my mode, the number that appears most often, I have 3 4s as leaves. So my mode is 34 because nothing else has 3 leaves of the same number with the same stem. That's about it. If I wanted to find the median, I could do that pretty easily. But the big thing is there's a couple of data points, min, max, and mode, that you can find pretty easily just by looking at the stem and leaf plot. Let's do one more with decimals. So let's create a stem and leaf plot for the data below. We've got 2.1, 2.5, 3.1, 1.9, 2.6, 1.8, 2.9, 1.6, 3.2, 3.4, 2.6, 4.1, 4.0. Woo! All right. So same idea in that my lowest, right, I have the 1s, I have 2s, 3s, and 4s. So my stems are going to be 1, 2, 3, and 4. And the process is the same. So let's start by looking at all of our 1s. Okay, so I've got 1.9, 1.8, 1.6. That appears to be all of them. Okay, so 6, 8, 9. Cross them out. Then I look at my 2s. 2.1, 2.5, 2.6, 2.9. Oop, nope, back up. 2.6. The smallest one of those is 2.1. So I have a 1. Cross it out. Then I compare. I have a 2.5. I have 2 2.6s. And then I have 2.9. Great. Let's move on to our threes. I've got 3.1, 3.2, 3.4. So 1, 2, and 4. Then, last but not least, I have two numbers in the fours. I have a 4.0 and a 4.1. Now, when you look at this, you can't tell that there are decimals. So it's important that we have a key where we show 1 line 6 equals 1.6. This tells everybody, hey, here is what we know. Okay, and from this, we can tell that our minimum is 1.6, our maximum is 4.1, and we have two leaves of 6, it's the most, so our mode would be 2.6. And that's creating and interpreting stem and leaf plots.